Yeah, so thank you everybody for joining. Welcome to our Fixed Wireless Network Reports webinar. It's obviously 2024 Q1. The particular data we're going to go over is 2023 and comparing it year over year to 2022. If you have any questions, please type them in the Q&A window. Some of them, if they're relevant, we'll try and handle right while we're at that slide, and others we'll try and do towards the end, but just type them in and we'll try and get to them all. For those of you who don't know me, I'm Gerrit Nagelhout, the CEO here at Preseem, and it's my pleasure to introduce you to really the man who needs some introduction in this space. I think many of you know him, but Jeremy Austin, our senior product manager here at Preseem, he is an absolute wizard on anything RF, fixed wireless, big data analytics. He'll be doing most of the talking. I'm more on the moderating side, but I'll try and get some questions in the meantime as well. Jeremy, over to you.
Thanks, Gerrit. Yeah, this is really fun. This is now, I think, this will be my 4th year with Preseem. So it's been really fun to see not just how traffic changes over time and how ISPs are responding to a kind of an ever-changing landscape of consumer demand, but also to be able to bring out new analysis that we haven't done before. We have a pretty extensive library of data, and I'll talk about that some as we get into this. It's really fun. For me personally, rewarding to be able to bring these kinds of things out. So if you haven't downloaded the report already, you can probably go get it right now and follow along with it at home if you like. There's a lot more content in the report than we will be covering today. I'm going to go over some of the highlights, and Gerrit will ask some probing questions, no doubt. But be sure to go ahead and get that report as well. You'll want to hold on to a copy of that. So one of the things that we do with our data is we try to determine what is normal and healthy by looking at our global set of customers. For us, customers are individual ISPs, and because we have a lot of them, and they tend to vary in size. There are you'll see a spread of performance. An operator who has maybe a coastal wireless deployment and is shooting out, pointing out toward the sea, and there are no interfering neighbors, may have a very clean RF environment, and somebody who's in like the urban jungle may have a very dirty RF environment. So you can't necessarily like pit an individual ISP against another and say, are they doing a better job than another one? But when you look at the entirety of our global data set, I mean, how many continents are we on, Gerrit?
Well, not Antarctica.
Not Antarctica yet.
I think all the others.
All the others. Okay, so
yeah.
all the other continents. We really want to be able to help you to understand what we're seeing globally, and that helps you because we're not necessarily going to tell you, oh, you're doing a terrible job. Again, how long is a piece of string? We'll still give you some baseline numbers that will help you understand where you fit in that ecosystem. Varying based on your demographics, on customer demand, whether people are doing video, a lot of different variables that go into making up the total package of demand that an ISP sees. And yeah, we have billions of metrics a day coming in. It's probably trillions. I think I think I was just downgrading it in order to be modest about it, but. We do collect an awful lot of data and crunch those numbers for you. So as we go through these reports, if you see omissions of particular things, it's usually because there aren't enough of them to be what we consider to be strongly statistically significant. If I've only got 10 of the latest access point that's coming down the pipe from a provider, and it is in beta in the field, I'm probably not going to give you data on that yet, because we won't have hit the maturity in the life cycle for that access point, and we haven't had a chance to really vet that data. So if you see omissions, that's usually the cause, is that we're trying to be sure that we aren't selling you a bag of goods just by not having a big enough data set. So we're going to just kind of quickly run through this agenda here. We'll be talking about some year-over-year comparisons. We'll talk about service delivery. We did this a little bit last year. We're going to talk some more about the busy hour online load ratio. That's a new one this year. Trends in wireless market share for vendor APs and CPEs. We'll be talking about latency versus throughput. Again, we're giving you another new comparison that we haven't done before, baseline versus peak on individual hardware. And then access point RF efficiency. I'm really happy about this one. This is one I've wanted to do for a very long time, because in many cases you have different kinds of access points that are suitable for different types of deployments. and it can be difficult to compare them against one another without like a universal metric of our RF efficiency. And then we'll do recap and Q&A at the end. So I'm gonna just go ahead. Gerrit, do you have a question?
Yeah. There's a question that's sort of a definition question. Why don't we answer that right away in case somebody's sort of waiting on that?
Yes.
So the particular question
it fits with this very first slide.
Yeah. It's can you elaborate on how active subscribers was calculated when determining subscriber download throughput peak versus hold times? What was the ratio of total subscribers versus active?
So I don't remember the precise threshold, but we consider an active subscriber to be one that's using more than, I think it's a few tens of kilobits. Does that strike a bell, Gerrit?
I think so, yeah.
Yeah, Dan could remember the number off the top of his head, but essentially, most of the time, a consumer connection sits idle. If you look at just the grand scheme of things, obviously there are individual subscribers who peg the thing all day long. Somebody is downloading game updates. But if you look at the average subscriber or the median subscriber, most of the time that connection's going to be fairly idle. So in order to determine what the distinction between the active subscriber and like your average subscriber would be, that would be the number that we would use to calculate like busy hour online load, which includes active and inactive subscribers. So I think probably the best mechanism to describe the ratio, because that's Samuel's question, is what's the ratio between active subscriber and like all subscribers, total subscribers. And I think it would be the ratio between the peak busy hour load, or the other way around, ratio between the active subscriber throughput and the peak busy hour load. So in this case, looking at this slide here that we're going to talk about, we're seeing a change up to 6.5 megabits from last year, 6 megabits at the end of 2022, which is about an 8% change. It's a little bit less than I was expecting. However, we'll get into this more as we go along. The busy hour online load has definitely risen in accordance with the usual growth that we expect to see. So if our not to jump the gun on this one, but we'll be seeing close to 4 megabits per second for the average subscriber. So that ratio is going to be something like 6.5 over 4. So it's about a 1.6 ratio, which means at any given time, about 2/3 of your, I think if I'm doing that math correctly in my head, about 2/3 of your customers may be active. Does that sound right, Gerrit?
During peak, I'm guessing, like in evening hours or anytime.
No, that's not during peak. That's just, sorry, the busy hour online load is during peak.
Yeah. Okay.
So the other thing to remember is that if you have a congested AP, the amount of throughput that an individual subscriber is going to get can be much greater when the access point is not busy. So you're going to be finding different points along those curves. They don't correlate directly to each other, because you don't know, if you're looking at like the total usage pattern of a subscriber, you don't know what time of day that subscriber actually had a peak. And in fact, that data is very noisy. It's not something that you can really do much with in terms of analysis, other than to just determine whether the access point is a little bit congested. We'll have more metrics coming out on that, hopefully in the mid future, because it's a really good area of study. And thanks for that question, Samuel. Hopefully we answered your questions there. So the total number of traffic itself is up 17%. That's what we'd expect to see. That growth, 17 to 20%, is very, very consistent year over year. Latency has also improved, though, and this is really cool. We'll dig into this a bit more. Last year, the improvement was not quite as good as this year, so I'm pretty excited about that. Any questions, Gerrit?
Nothing here, thank you.
Great. Okay, so we're going to talk about now plan speeds and service delivery. What are people actually delivering? This is one that's really fun. We have subscribers using many different access technologies, not just wireless. And thank you, Samuel. On the upper end of this, as you get over 400, 500 megabits per second, those plans are going to tend to be fiber. Some of them will be milliwave, but in our user set, more of those will be fiber. So the trend line, which is what we're drawing here, we're not drawing all the individual samples, but the trend line of how much bandwidth the user is using when active versus the plan speed, it has about the same slope as it did last year, maybe a little bit steeper, in which case we're seeing some increased use on the bigger plan speeds. But essentially, if you look at the difference between a 200 megabit plan and an 800 megabit plan, which would be a 4 4x rise, you're only seeing from about 4.5 to 8.5. You're having to more or less like quadruple the plan speed to double the usage. You'll see some more of this in future graphs. This is the sort of thing that should set your mind at ease as you start building bigger plans. Serving someone a 10x plan, going from 100 megs to a gigabit, does not create a 10x rise in demand on your core network.
Although if you go from 1 to 10, you might.
From 1 to 10, yes. And from 10 to 100, yes. And we'll see that again in greater detail as we go forward. This is a good example of it.
Yeah.
Yeah.
Oh, yeah. No, there was a question on latency 2 slides ago. Is it average latency? Like the reduction, I think, in latency
we'll get
improvement.
into that. We'll get into that when we look
later.
at that slide. Yeah.
Yep.
I think I took the mode, but yeah, we'll get into that. So so as you can see, this is like the total amount of data that is usable during a month. The blue line is the 50th percentile, so this is your median user. And then for comparison, I put these upper percentiles where you can see there's a big spread between the 50th and the 95th percentile. It's almost 4 times as much data at the 95th percentile. But what's really interesting about this is that the under what I call kind of this knee here. Let's see if I can draw a line there, which is under that 50 megabit mark. So definitely around the 25 to 50. People really are being constrained by their plan speeds. We've seen operators that are selling, small plans, see those plans be pegged a lot of the time. Like it's just consumer demand is going to continue to rise, and if the plan speeds don't rise along with it, then what happens is those plans get maxed out, right? So we see kind of several inflection points in terms of where the slope changes. I've kind of marked the one at 100 megabits as one of interest, but even the one at 200 where it flattens out even more. It's really interesting to see that it's, this is almost flat above 150 megabits per second in terms of how much data a given user is going to use. What will happen is they're going to get it faster. They're going to get on and get off, but it doesn't create greater demand. Doesn't mean that they're suddenly going to change their usage patterns and continue to peg the thing all the time. The same thing is true even at the 99th percentile. That is the heaviest users on the network. It really starts to flatten out over about 200 megabits, and then that is in part due to the fact that there are very few services on the internet that can just steadily peg your connection at hundreds of megabits. Apart from like downloading the occasional game update, even streaming 4K video to multiple TVs in your house isn't going to generate a crazy amount of demand for hundreds and hundreds of megabits.
And I think that's fairly similar to last year too, right? Like this. I know the numbers have changed a few percentage points.
I changed the way that we're displaying it a little bit, but this is other than just increasing. No, this is very similar to I think maybe that knee is moving a little bit further to the right, which is what you'd expect to see as plan speeds rise. But very definitely, if you are selling 25 meg plans as your bottom plan today, those people will be constrained over time. Okay, next one. We're going to cover. Okay, so this is a new one. This is a plot of kind of a density plot here of the download busy hour online load. That's very simple. It's the total aggregate traffic of your ISP divided by the number of subscribers that you have. So it's megabits per user. And then on the y-axis on the left-hand side, we have the upload. So if we look at the histogram of this, we can see that the median of this data set is really right about 4 megabits in the download, and in the upload, it's actually still quite low. It's less than half a megabit. So the trend line itself, let me pick a different color here. Let's do something like this. The trend line, I'm going to just sketch in here, is really quite consistent across ISPs. Yes, there are some ISPs that are delivering an average of 10 megabits in the download, but there are far fewer of them than you might think. And yes, there are ISPs that are delivering less than a couple megabits of throughput per user, but there are very few of them. Most ISPs are really getting to the point of maturity where they're actually able to deliver that customer demand. Any questions about this, Gerrit?
Yeah, so it's interesting. The ratio between up and down as you drew the line is pretty consistent. So they seem to be, as you go up, both the down and the up go up as well. What do you think accounts for the range here? Like there's a big range between just over 1 at the left and over 10 on the right. Is it plan speeds, demographics?
So plan speeds is the primary cause of the ones on the left-hand side, rather than demographics that I'm aware of. Because if you have the same applications available globally, you're going to tend to have sort of the same data patterns. And usually what would constrain that is just the cost of bandwidth. You're selling small plans because maybe your international bandwidth is really expensive, and maybe you don't have a lot of local content, and so everything's coming from overseas. We saw this, just even in Alaska, where where I'm from, where the cost of that middle mile to Seattle can be high enough that you're going to end up having to sell smaller plans, or charge more accordingly, and therefore have less uptake on those bigger plans, because you're constrained by the total cost per megabit of this busy hour online load. If you're paying multiple tens of dollars per megabit, you can't sell a $50 plan if the average user is going to use 4 megabits, right? Found that out very early on. On the right-hand side, I haven't dug into that side as much, other than to prove that it's real. They tend to be, again, operators who are selling those bigger plans, where we should expect to see some growth, or they maybe have more fiber in their network, or maybe more milliwave, or some of the newer technologies that are actually delivering more capacity per access point.
Yeah.
Make sense?
Mm-hmm.
Okay. And as we said, this slope is beginning to flatten. It absolutely is. Used to be 10 to 1, 11 to 1 was pretty much standard, and you wouldn't be experiencing much constraint. We are seeing more upload usage, and I think currently I would characterize this slope as approximately 8 to 1. It may be a little bit less than that, because if you look here at 8, we're kind of right at the 1 mark. So approximately 8 to 1, but I would expect to see this slope continue to decline a little bit. It might take us a couple years to get to 5 to 1. I don't have a crystal ball there, but that would be something like 100/20 plan. We're really not quite there yet. We're definitely not in a world in which most users need symmetric services. Most users do not. Someone who's transferring large medical files back and forth, absolutely. Someone who makes video content for a living and is uploading high quality files to YouTube, like myself, I really would like to have better than an 8 to 1 ratio. And we'll just have to see what we can do in terms of on the technology front.
Yeah, there is one question here. Can it be equipment constraints that's causing lower upload versus download? Like, could
It
the upload be
absolutely
constrained, I guess,
can.
relatively more than a download?
It can, but it's rare, because most radios are going to be configured at something like a 70, 75, 80%, which would be something like a 4 to 1 to a 5 to 1.
Yeah.
And so in general, that means that they're not going to be constrained in upload. They're going to be constrained in the download first. Obviously, there'll be individual subscribers who have traffic patterns that don't match that. But in general, current TDD splits are better than 10 to 1, right?
Yeah, lots of
You find that
80%, 75%, that kind of thing, right?
you find that if you try a 10 to 1 split, then you're constrained by the latency of being able to get those ACKs back up, because in the upload, it's more critical that you have that you have free airtime to actually be able to transmit those ACKs, rather than like you're going to be continually pegging the upload.
Yeah.
So the average usage is going to be misleading, because the average is not the same thing as the peak usage.
Yeah.
And it's that instantaneous. I like to say, you're either transmitting traffic or you're not. There's really no such thing as this average rate, right? You're either sending a packet or you're not. So if there's airtime available to send that packet in the upstream direction, that's going to keep your latency as low as possible.
Yeah.
So there's obviously diminishing returns. You don't, your overall latency is not going to dramatically improve by going to a 1 to 1, as we've seen, but it will improve over something like a 10 to 1 quite a bit. Does that make sense, Gerrit?
Yeah. So with that, I guess with that ratio changing a bit in favor of upload, we know today with the ratios that we see between receive and transmit, we're okay. But should operators think about changing that in the future? Or are we still well in the golden zone for now?
Again, until we start seeing constraints in the upload, we're going to be saying it's probably okay what you're doing. Once we start seeing constraints, then we'll be reporting on that. The other thing that we could do is do more reporting about the different percentiles, because again, this is the median, and the median doesn't always show you what's going on at the extreme ends, the idle end and then the active end. Because when you're looking at a hockey stick curve where you have these two states, it's either busy or it's idle. It can be very difficult to pick a point along the middle and make a prediction about that point. So sometimes you need to look at more of the percentiles in order to make a prediction about it. But that takes more space on screen.
Yep. Cool.
And
One more question
we've
here.
got a question. Yeah, go ahead.
Yes. So it's does this report include, I guess, business, commercial, and consumer residential of fixed wireless?
Yeah, the majority of this is going to be residential, but I am not aware of any of our customers that make a significant differentiation from a service delivery perspective and don't run their business services through our data collection. So
Yeah.
we do tend to have um, uh, uh, see consistent results across that. You're going to have a different daily peak because the business users are going to peak during the day. So the business users don't really skew the ISP numbers very much, even if it's a big business, because that
Yeah.
tends to happen at a time when the network is less idle. Anthony made a comment that he switched to symmetric plans with no uptick in upload usage. That's what we'd expect to see. The one caveat about that is that it's rare that you can truly do that in a fixed framing environment without some consequence. And flexible framing kind of has its own caveats in terms of total system efficiency.
Hmm.
But that's outside the scope of today's one. So to get to the latency question, how much is this improvement? Yeah. So the blue line is the current year, so Q3 of 2023, when we ran our report. And you can see that it has shifted significantly to the left and up here. That's that 9% that I was talking about. Another thing that's notable about this is that we're now for the first time seeing less than 1% of overall samples. That's not overall packets, but less than 1% of overall samples are in that 200 and above bin. This bin here, which is why you see a little uptick here, it's because it's adding up everything that's to the right of 200. So it's going to be a little bit fatter than the 195 bin. And we're now seeing that below 1%. Now, in a perfect world, I would love to see, everything between here, 150 and 200, be under 1%. So maybe with your help, we can get there over some time. But this is definitely a good showing. This means the operators are continuing to improve their network even as that customer demand is growing.
Yeah. And it's really awesome to see this, right? Like for those of you that know us for a while, and many I suspect do, we care about latency a lot. So it's a real pleasure to see this shift. And I guess I'm wondering why this shift, right? Again, most all this data is from our customers, so they got all kinds of tools to make this better. But do you think it's companies optimizing the experience, or is it, old gear with higher latency being replaced in favor of newer gear? Like what do you think of some of the drivers behind this fairly substantial shift this year?
Well, there's you can reduce latency by reducing traffic. There are fewer ISPs that are doing that are sort of artificially constraining that consumer demand. We call it load shedding. If you have a part of the network that you can't upgrade and you don't have any alternative, we don't see that to be very very common. But that would be one potential cause. So just based on how uncommon that is, I would say that's not the major driver of this. I
Hmm.
think it is. We'll look at the equipment numbers here on the next slide, Gerrit, and we're going to see that there's been a downturn in higher latency equipment, which might
Interesting.
be enough to shift it. Just simply upgrading to newer equipment, as well as perhaps some better internal management. We know that traffic at the edge is growing pretty dramatically. We'll see that as well with some of these. The fact that we are seeing bigger plans. We didn't put the plan distribution in, but that's going to continue to rise. And so for consumer bandwidth to continue to grow, usage to continue to grow, and the plan speeds to continue to grow, both of these simultaneously,
And
they operators must be improving their backhauls, their core routing capabilities. That usually doesn't add a lot of latency, but if it's badly managed, it can. Backhaul constraints
yeah,
would cause a dramatic increase in latency across a lot of the network.
yeah. And I would think that a lot of this latency is going to be the access point layer, though, right? Like, and one of the questions actually is from where is this latency measured? And I'll answer that one. It's so this is based on inline traffic metrics. So Preseem's inline in the network, typically in the core, we measure TCP round trip time. So it's how long it takes for a packet to go from the inline device all the way downstream. So backhaul, AP, CPE, through home Wi-Fi. That includes that to the end user device and all the way back again. So that round trip time we're constantly measuring. But I know from looking at probably tens or hundreds of thousands of charts by now. The AP is a big chunk of it, but you have in certain cases it's home Wi-Fi that makes it way better or way
Mhm.
higher as well. We're sorry, but But I think in general the APs are going to be the point to multipoint piece is a substantial chunk of this.
Yeah, we do see occasionally, as I said, occasionally backhaul
Hmm.
constraints that would increase latency where there's, buffering or retransmits happening at the backhaul layer. But hopefully that doesn't continue to grow. That may, for a time, temporarily be a problem as people put in faster edge equipment and then realize, oh,
Yeah,
demand has risen. The good thing about doing capacity planning and prediction is that the rates are still relatively constant, 17 to 20% year over year. And if you can stay ahead of that in your engineering, then you don't even actually need us to tell you, other than to confirm that that's still happening, right?
yeah.
You can do some of that capacity planning quite easily at the big pipe level, and we'll hope to get you some more tools on that front as well to tell you specific dates. We don't want it to make you have to do it all by hand. Okay, where are we? We are doing vendor market share. All right. Yeah, I had this slide here about wireless as the new hybrid because everybody's doing everybody's doing wireless. Even those who are putting in fiber are like, and there are these pockets where we can't hit with cost effectively with fiber. And there are new tools available to us in the wireless world. So it's kind of continuing the trend that wireless operators are beginning to deploy fiber. And I don't know what percentage of our customer base, might be as high as 25%, Garrett, that are doing both wireless and fiber, started in wireless and are adding fiber in. So
Yeah.
it's absolutely gonna keep
We'll
happening. So
we'll have a lot more data on that next year, I think.
yeah, exactly.
Um,
Um,
there is one question here related
yep.
back to latency. So Sean says they've added 2,400 more than 2,400 fiber customers in the last several years, and in their case, it offloaded a lot of load from the APs, from the wireless APs, which then increased available airtime capacity, of course, and all of that. Do you think that's happening widely enough to be contributing to what we're seeing in that latency shift? Is that a major factor, I guess?
I think it's definitely a factor. We don't break it out yet. We were hoping to break out fiber and wireless this year, just kind of being the tipping point, but where we would want to say, okay, now we have so much fiber in the field that we really want to do that comparison for you. I think that's going to end up being next year's report, or maybe in the fall, maybe do a
Mhm.
midpoint report, because we are getting more and more of that. And at that point, yeah, you might see that latency number hold constant or whatever. Don't discount milliwave as well, though, Sean. There are lots of cases of people installing more lower latency um, uh, access gear, and we'll see that in these numbers as well.
Yeah.
So,
Well, and then the other one is 6 gigahertz. There's a question from Kevin about that. Do we have any
yeah,
information from 6 gigahertz? I'm guessing not much yet, but you'll know for
we
sure,
don't have it
Jeremy.
broken out yet because I don't believe there's enough of it to be statistically significant.
Yeah.
So that you
But
will see some mixed in here, but it's going to behave just like 5 gigahertz. It's not
yeah.
going to be any different.
But
It's
I
going to be the radio technology that matters, not the frequency.
yeah. I wonder if we're going to see the same trend there though, because I know a number of conversations I've had with our customers that have particular areas where they're congested or subscriber capacity scores show that they're full, of course, and all of that. And then they're using that to pinpoint where to put the 6 gigahertz gear to offload those as well. So I think there'll be some interesting trends there over the next year for sure. But yeah, that's going to be very light at this point.
Cool. So there were a couple surprises here in this one. Ubiquity on the CPE side. I think a lot of this really is being driven by that push into milliwave. They've had a great deal of success with the wave gear. I didn't break that out specifically here, but that's one possible content, because you'll notice that the total number of APs as a percentage of the market has dropped for Ubiquity. Kind of the reverse for Cambium. Cambium is seeing some offloading there, and still an increase in AP. So operators are still deploying. That could be the 4500s, 4600s. There's definitely opportunity for both of those vendors as this is happening. Dimitri's asking, what's the overall growth? We don't publish that number because that's private to our. Remember that
Yeah.
what we're seeing is our customer base, and yes, there is growth year over year. But that wouldn't be representative of what the total market is. Garrett, you could speak to a little bit about
Yeah.
that on the organic growth
I
side, though, right?
yeah, I can't. I don't have an exact number, but definitely the fixed wireless number of subscribers is growing more slowly than it did a year ago. Certainly than 2 or 3 years ago during COVID, whatever. It shot up then, and that's certainly leveled out a bunch now. And I think that's partially fiber and other reasons like that as well.
Yeah. MikroTik is seeing a downturn here, which is interesting because we have seen a lot more MikroTik gear this year. So an increase in the total number of APs, decrease on the on the CPE side. The real big growth story here is the LTE versus Tirana, and we are definitely seeing a significant downturn of the LTE 4G gear. We don't have enough 5G gear to make predictions about it. The big operators are doing 5G. I have yet to see that really take hold in the fixed wireless, in the smaller independent fixed wireless space. We saw a significant downturn in terms of the total market, about a third, kind of a 30% drop for buy sells, and a similar for Telrad in the marketplace. And that's clearly being picked up by Tirana, which went from under 0.5% of the total market to 2% of the total market, which is a significant. That's a 4 or 5x in 1 year's time level of growth. So I would expect to see that continue to grow over the next year. I don't have any evidence that that's not going to change. The APs haven't quite doubled, but what we're seeing is coverage come first, and then an increase in installed base, as you'd expect with a new product line.
Yeah, and it's interesting. I know some of our clients have had, I think it was Telred and 2.5 gigahertz, if I'm not mistaken, where that they had to get rid of it because of spectrum licensing issues or whatever. So that probably contributed to this as well. It is fascinating seeing Ubiquity going higher density, so more CPEs per AP, and Cambium going the other direction. I don't know why that is. It's
Well, I think it's
interesting
because
trend.
of the new lines coming in. Because
Yeah,
remember when the new lines come in, like the 4000s, they start out with very few subscribers per
right.
AP, and they have
Yep.
to. We'll talk about that more as we get to some of the other hardware. It takes you have to look at the kind of the full life cycle to see where is it going to be saturated. We'll talk about this on the when we get to talking about Tirana a little bit more. Some interesting
Yeah.
stuff going on there.
Yeah, and of
And
course,
this
Toronto will they be third next year? Will be the big question as well. They're going up pretty quickly.
will they supplant MikroTik? You mean?
Yeah.
Good question. Yeah, we'll have to see how that goes.
Hmm.
Dimitri also points out that there's vendors are improving the software over time. That is a good point. Rarely do we see that it dramatically affects latency. That tends to be like incremental gains in capacity. But sometimes we see an improvement. It's not often. We do watch that kind of thing over time though to see if there's anything notable going on there, Dimitri.
Hmm.
There is sorry about the circle size. It's just the same thing as the latency here. On the y-axis, we're looking at the idle latency, the PO5, the 5th percentile. So what's the best latency we can get out of this at idle versus the 80th percentile? What are we going to see under load, which is that primary line that you'll see in the Preseem interface for latency? As expected, LTE has a high baseline latency and a high loaded latency. It's almost 25 milliseconds when idle, and can be well over 100, 150 with Telrad and buy cells. They're going to be very similar. The Telrad have tended to be loaded up more, which is why that's a little bit to the right of the buy cells. This Breeze Compact here in the upper right hand, this one over here. So they just simply have more users on them, and so you're going to see a bigger change when they're under load. You can see some pretty standard clustering here. Milliwave is, as always, very low. Some of that is that idle latency is under a millisecond. It's really fantastic. The LTU also has good idle latency, but a little bit more increase under load. LTU is one of those things where it doesn't quite. You'll see this in some of the numbers. It doesn't quite load up in a way that that scales the same way as something like a MU MIMO system, the PMP 450s and 450Ms. Because the other axis that you're not really seeing here is like what's the average number of subscribers per access point. And I probably should have put that on this chart as the circle size, Gerrit. My bad. I'll get that next time. As you'd expect, the Wi-Fi based chipsets have a higher latency here, like the 3000, the 2000, the Prism actually is impressively good at idle. There's a little MikroTik sitting down inside there. And then the 450s are pretty closely clustered. 450M and 450, very similar. 450M has slightly better latency at idle, and statistically insignificant higher latency under load. Tirana is in here for the first time as well. Note that it has slightly higher latency than the 450 platform, but almost identical in terms of latency under load. In practice, when you actually load that thing up and people are experiencing that peak busy hour, it's really sitting right in there in terms of the amount of load that we're going to say. It's not a dramatic. The advantages with Tirana are going to be coverage and capacity, not a significantly lower latency. Does that make sense, Gerrit?
Yeah, for sure.
Excellent.
Yeah,
Let's
it's
go through some of these
fascinating
pretty
seeing this
quickly
all
here.
play out.
Yeah, let's go through this a little bit more quickly here. Again, most access points, and we bear that slide that we just saw in your mind, most access points are idle. They don't have a lot of customers on them. The vast majority have, 10 or fewer. So we think about sort of the median access point. It's not a big loaded up Tirana or 450M Medusa. It is going to be some smaller radio that has fewer subscribers on it. That also bears into what I was saying about most access points not actually being congested in the download or the upload. The parts that are going to affect your network are the ones with a lot of traffic. So from a statistics perspective, everything here on the right hand side of the curve is going to be what influences your actual ISP level stats more, because these access points are going to tend to be the ones that are maybe a micropop, or they're just not a lot going on them. It's very clear looking at this that the market still needs low density solutions. The fixed wireless market is still being deployed in parts of the world where it doesn't pay to go install super high density solutions. We still need low power, low density solutions. Looking at this broken down by model, I've gone ahead and added in the maximum sample that we see. Gerrit was teasing me because it's got a fractional
Right.
CPE on here. Yeah, rounding. Yes, that's that's probably a percentile, Gerrit. So it's a little bit. It's not the 100th percentile. It's probably 99th. Fractional users, yeah. But we can see not much change here. Again, there's a lot of clustering with the Wi-Fi based chipsets here in the middle, where they kind of tend to have about 8 to 10 subscribers at the average. That's that big spike I was talking about, and very similar numbers when loaded up. Not a huge amount of difference there, kind of the 25 to 30. Frankly, I think performance is not great when you have this many on. So that's the P95 here. We don't really recommend that you load them up that high, right? And then similarly, like there's a 450i here with 83 users on it. Again, that's not broken down by channel width. So take that, understand that this includes all of the possible channel widths on it.
Hopefully not 900 megahertz.
Yeah. So 450M. So when we showed this, I don't remember if it was this one or not, but you'll notice that Tirana is coming in here a little bit lower in the deployment stage than the 450M. And this is not a surprise at all, because Tirana is still being deployed. We're only really about a year and a half into its deployment model, whereas the 450M has been out for a long time. And these numbers are kind of reaching saturation or maturity, where we're seeing about 150 at max. We are seeing some pretty impressive numbers on the Tirana, 128, 130. But we know that these numbers are going to drop for a bit as ISPs move from, okay, I'm going to test this in my busiest areas of the network, which is what we saw initially. Some of those initial results from Whisper, for example, where they said, we're going to replace 150 user AP of a different vendor with Tirana and test it out, because that's a fair test, right? Load the thing up. And that test went well for them, as they have said very publicly. So I would expect to see these numbers continue to rise over the next year or so. I don't believe this is a failure in any way. I think we're gonna as those get maturity in the marketplace, we're gonna see those numbers come back up. After we've got, we did the testing phase, we did the deployment phase, where now there's a bunch, it's hundreds and hundreds of idle APs with nobody on them yet. And that's gonna continue to change as the market matures.
Yeah, and I guess we're not seeing a ton of congestion on Tirana yet either. Actually, the previous latency
We are not.
slide,
Yeah, they have not peaked out
right?
yet.
Yeah,
Yeah,
so
they haven't
it
peaked
looks
out
like there's
yet.
generally room to grow.
Yep. And so the throughput numbers are pretty good looking here. Again, for Cambium, we are seeing at 95th percentile at 188 megabits per second. Our 95th percentile for the Tirana is significantly higher than that. Again, that's not comparing spectral efficiency. So you have to look at how much, Toronto, you can do reuse one, but you might be a wider channel. So you've got to look at the entire spectral picture in your area to determine how efficient that is for you. We do have some numbers on what we're seeing for that. Clearly, there will be what do you call it? It will become more comparable as more get installed in the marketplace. LTU Rocket is doing reasonably well here with the 3000. So very similar numbers, a little bit higher on the peak side than the 3000s. We don't see 4000s yet on here because there just are not enough for my satisfaction to really be able to show you, hey, what can these things do? The 4500s, the 4600s. It takes time to get them loaded up where you can then say, okay, now we're pushing them and we can tell you exactly what you should expect to see out of them in the best case scenario. One thing that surprised me is actually how well Mimosa is holding up over time. Mimosa is still holding up reasonably well, even with their their 5X series. The A6 stuff, I don't have enough of them to show you that yet, but that kind of been a sleeper for me. I've used Mimosa for many years, but I've been pleased to see that they're really still holding up in the marketplace against some alternatives. Really interesting point there.
Yeah, it's neat seeing the change in order as well between this and the previous slide. So Toronto wasn't at the highest at the bottom before the number of CPEs, but here it is. So I guess that means they have relatively
For
higher plan
throughput.
speeds or higher throughput
Higher
per
throughput, yes,
subscriber as well.
exactly. So it's more speed per user, or sorry, more usage per user. Yeah,
Yeah.
because that's exactly what you expect to see if people are serving multi-hundred megabit plans. Because you can't do that on Mimosa. Sorry, you can't do that on Medusa either.
Mhm.
You're going to be limited by that 64 QAM. You're going to be limited by the channel width, right? You don't have as much multiplexing going on, so you can still push a fair amount of data to the more customers, and we'll see some charts on that too. That's a really interesting one that we have a new chart for you on that. Upload, very similar. I'm not going to dwell on this. Again, I think we'll see the Toronto numbers continue to rise over time. The Cambium is sitting at the top of the heap right now, but not by much. I don't think that there's an RF difference. I think this is just maturity and saturation. Again, they are, Toronto and Cambium are a significant chunk above the rest of the market in terms of the overall efficiency. Okay, now we'll get to those capacity numbers I was wanting to show you here. This is a new one for us. So the length of the line is showing the 95th percentile. So the right-hand end of each of these lines is the 95th percentile for each model. So if we look at some of the Wi-Fi based chipsets, we're saying, what is the efficiency in bits per hertz? That's the y-axis here. So I'm going to grab a different color so this will stand out a little bit better. But if we take a look at the EPMP 2000s, we can say, well, we're averaging just under 5 bits per hertz if we put one user on it. If we load that thing up to 20 users, we're tending to see something more like 4.5 bits per hertz in terms of total system efficiency here. This y-axis is not linear. It's 10 to 4. It's not 10 to 0. So bear that in mind. I zoomed in to allow you to see this. So that can be, I have two possible explanations for this. One is that you actually do see, due to additional contention, you do see a reduction in total efficiency. And I think that's true for the Wi-Fi based chipsets because we see a significant pattern of that nature. The other is that the busier deployments are probably going to tend to be a little bit more lax on total system gain. Like you're going to allow customers a little bit further out. There's probably going to be more noise. So overall, all in all, if you're stretching the capacity of that AP, you're going to see a reduction in efficiency. So similarly here for the Radwin Jet, this is one that I observed quite a long time ago, is that efficiency really tanks as you load these things up. They don't handle congestion very well. I was recommending don't go past 15 or for the Radwin Jet. Starts out reasonably well, but then continues to drop as you add customers. So bear that in mind when you're thinking about total system capacity. You could add more customers, but that doesn't necessarily translate to more throughput. And similarly, I would say one that you'd also look at would be the EPMP 3000. This orange line here. Again, we are able to put more users on them, but you do see a decline, slight decline from about 7 bits per hertz, just under 7 bits per hertz, to down to about 6 bits per hertz. The LTU up here, this one surprised me a little bit, but I don't know the proximal causes for this. It starts out very high at 10 bits per hertz and then continues to drop pretty steeply. That's consistent with what I've heard as anecdotal reports from people in the field, that efficiency does drop as you load them up. I don't know the technical reasons for that. That would be something that would be fun to investigate. Why does it drop so much? It's dropping, about 10% as you near the maximum capacity. And notice this 95th percentile, we're not seeing many more than about 24, 25 CPEs connected to an LTU base station. 4600, I put on here, it's very early, so I wouldn't read a ton into this. It's similar to the LTU in terms of the drop, but I would expect over time that the ePMP 4600 would have a slope more similar to the 3000. So I expect that slope will flatten out a little bit as we get some maturity in the marketplace. And likewise, I would expect to see this line will get longer, more users will be connected to them. By contrast, the non-Wi-Fi based chipsets, you'll notice here, this is Medusa. So notice it starts out relatively low in efficiency, just above 5 bits per hertz, but then continues to rise. As you add customers, your overall efficiency rises, which is what you'd expect to see with an increase in gain. Now, there are diminishing returns. Our 95th percentile is still, about 70 users on an access point. But that's the fun thing about MIMO, is the more users you have, the more bits you can push. Similarly, we are seeing with Tirana a very gentle rise here. I would expect that to maybe get a little bit steeper as Tirana reaches maturity in the marketplace. The other thing to note is that you are dealing with a significant bump already with Tirana in terms of bits per hertz. It is almost 8 bits per hertz here, not quite at the level of the ePMP 4600 or the LTU, which is to be expected given the types of deployments. Those are LTU and the 4600 would be more line of sight deployments, high modulation, very short distance, whereas Tirana is doing those multi-path, slightly lower efficiency, but let's add more paths to the destination and get some efficiency that way. So overall, we are seeing a significant increase in total system efficiency over Medusa, which is what the back of the envelope calculations tell us that it should be true. It's nice to see the real world deployments telling us that that's true as well, because everything depends on how the operator deploys it. If the operator doesn't deploy it the way it was designed to be built, or the way that the vendor recommends, you're not going to get the same performance out of it, right? Anybody can go put in a radio and run one of these things at 1 bit per hertz. We do not recommend that, but you can do it. Okay. Any questions about that one, Gerrit, before we go on?
No, it's just fascinating, the different families, and the 4600 being that much higher efficiency than the older Cambium gear, and then Tirana starting off very strong. It's obviously, if you're optimizing for your spectrum usage, then I suspect many of you are. This is something to keep an eye on.
Yeah. Dimitri was making a comment about the different channel widths available in LTU, 802.11 gear, Tirana. This chart is independent of channel width. That's why it's based on efficiency in bits per hertz. So this is including, like for the 2000s, that's going to be all of the channels. I didn't break it out into 10 megahertz channels, 20 megahertz channels, 40 megahertz channels. In general, the efficiency drops as you widen the channel. But all else being equal, let's take the kind of the average of what you can do for this gear. This is the true way to compare apples to apples.
Yeah.
Okay.
And then there's actually a question as well from Henning
What was
on,
there?
would the efficiency decrease with distance distribution? So if you have mostly nearby users versus remote users.
Absolutely, Henning. Yeah. That's partly why I was saying, like, as you add more users, that I suspect, though we haven't run the math on this, I suspect that the average distance to the user increases as well, because an operator is aiming for more coverage with that access point. And so that's going to reduce your signal to noise ratio for that given customer. If we were to compensate for this by signal to noise ratio or by distance to the customer, then presumably you would see like a flat line, right? Because you'd be shaking that out of the equation. But because operator deployments are what we're trying to get at here, we want to show how people are actually deploying them. We assume that you can't change the distance to the customer, but you have a choice as an operator of where you connect that user to your network. Do you connect them to a closer access point that maybe is more congested, or do you connect them to a further access point where you have to put in a higher gain antenna and it's got some capacity, but now you've stretched that link a little bit further than maybe you should? There's a lot of variables that go into this, and a lot of operator control over that picture. So one of the nice things about understanding what the baseline performance of the access point should be allows you to understand, okay, are we really getting the most out of this series that we can? Because there's, if you look at the diversity of equipment that's in the marketplace, clearly there is a use case for every single one of these types of gear, right? There are none of them that are superfluous. They all have excellence in some, whether that's low cost or high performance. There's a reason that all of these exist. And there's a reason that operators have used them and relied on them. So I hope that answers your question, Henning. You're absolutely right that the distance to the end user significantly affects, how efficient you're going to be able to modulate to that customer.
Yeah, and probably optimizing all of that as a whole topic in itself. It's lots of complexity there.
There are many PhDs have been written on that on the mobile capacity planning world. Absolutely,
Yeah.
and fixed is not much different. So we still are seeing the majority of access points are still running at 20 megahertz. We have seen a significant rise in those wider channels. Some of that's due to Tirana, and some of that's due to milliwave stuff. We've seen about probably about a whole 1 to 2 points rise, which is consistent with what we've seen in the hardware growth as well. 30 is still very unpopular. It's a very difficult channel to do channel planning with. 30 is still very rare. In terms of the subscriber download throughput, again, bearing in mind that 30 isn't really significant, there is a difference between 10 and 20, which implies to us that radios that are running 10 megahertz are tending to be older deployments where maybe you need that extra system gain and you really aren't able to deliver a wider plan, a fatter plan, because you're constrained by the 10 megahertz limitation there. These wider channels, 20 and 40, are largely used to deliver to more customers. There's not a big difference between 20 and 40. 40 through 100, those are those wider channels I was talking about that have risen. We do see a bump there. That would be consistent with what we know of the gear that's being deployed and the plans that are being sold on that. Milliwave, of course, has the highest capacity overall. Those are basically fiber-like, and we do see a bump there. We do see that people are selling bigger plans on them, and you would expect to see higher throughput. This isn't normalized by speed plan. And then similarly, total number of connected radios by access point channel width, again, 10 down at the, just single digits, 2 and 3 subscribers fitting in that space. This is the big one that we've seen growth. In fact, we broke this out into its own category this year. I believe those 1 gigahertz ones are going to be a lot of waves. So there's a lot of these almost point-to-point like connections where the gear is now cheap enough that you're able to put just a few customers on them and deliver these really, really high-speed plans. We're seeing some growth there. Let's see here. One more, which is this one. Okay, so this is access point capacity when nearing saturation. So this chart does not have Tirana on it, and that is because we're still waiting for the firmware that would let us produce this report to be fully deployed in Tirana's user base.
It's available, so but it's fairly new, so yeah.
It's not fully propagated out yet, so we don't have enough. Yeah, we've been asking Tirana for this for a while because we want to be able to show this for Tirana as well. And it's interesting to see the total user capacity. Again, this is going to vary depending on the consumer plans. So if you're selling higher plans on Tirana, that won't necessarily translate to more customers versus a Medusa with smaller plans on it. So you definitely have to ask yourself, how long is a piece of string? But the Cambium 450 at 40 megahertz, for example, has a 50th percentile of 43 users on that, and at 20 megahertz, right about 26. So this bears out what I was saying before, which is that wider channels tend to be used to be able to serve to more customers. This is worth looking at if you're trying to do some basic planning and you don't have some baseline numbers yet to understand what am I going to actually be able to deliver. This will vary in your own ISP based on what your ISP's peak busy hour load is. It will be calibrated precisely for that. So when we go back to that chart to show the wide distribution of busy hour online loads, this is going to be the average across all of them. So any capacity numbers that you see in Preseem are going to be customized for your ISP specifically. But this could be a helpful guide to understand the distinction between different vendors. So yeah, we're not trying to hide Tirana on this. We just don't have the data for them yet. So to cap, please get the fixed wireless report if you haven't already. There's a lot more stuff in here. We break down the latency by subscriber usage. There's subscriber density on the APs, oversubscription. We talk about throughput by channel width. that is available now today. And just to recap again, we're seeing some latency improvements. We're seeing some growth. Lots of fun things happening there. No real shockers, but it's really fun to see this this data be both consistent, but also tell us new things every year. I really have enjoyed this. Gerrit, do we have any remaining questions?
We got 2 questions, and we'll see if anything else comes up. These were a little bit outside of the slides, so I've held on to them to the end here.
Okay.
All right, question from Kevin. What are your thoughts on private 5G and our N96, N104 sharing the 6 gigahertz space with other fixed wireless using that space?
That sounds like a policy question, which I don't know that we would comment on. Our customer base is global, and so different regimes have different use cases for the spectrum. So we don't generally weigh in on questions of what's an appropriate use of spectrum. We can just tell you, how well is it being used. In the case of the access and backhaul with 6 gigahertz 1260, again, many of our operators are doing multi-play stuff, but the thing that we find about whether it's disaggregated or aggregated backhaul and access, the capacity planning still has to come into play. You still have to be able to understand what the equipment can achieve in the real world. So I can't speak to whether or not that's a good idea for our customers to do, but yeah, it's absolutely due diligence must be done. Henning's asking, do we measure packet loss? Yes, we do, Henning. We measure, again, if we see a TCP, we measure for TCP, and we do collect the raw interface stats if there's packet loss at the interface level. But if there's loss at the TCP layer, then we're going to see that as a retransmit. So Gerrit, any comments on that?
Yeah, and we find we typically find that latency is a really good one for finding congestion at the AP level, for example. It's the number one indicator that we look at. I find that retransmit charts are super helpful at a system level or a server level, right? If you have a 10 gig transit getting maxed out, right, and you're getting close to that, or TCP retransmit will show a little humping along the line, along with the flattening of the bandwidth. And so you can find some really interesting things looking at that level. Maybe the question is related to, we haven't really talked about retransmits in this report. I think as latency is more telling, but maybe you have something to add on that side as well.
In general, a certain amount of loss is good. That signals to TCP that it's time to back off. So it's definitely worth paying attention to that. We haven't showed that over time. Our ISPs doing what do you call it? Are they doing a better job managing that? The other thing about the loss is that there are other causes of loss. Loss can occur anywhere along the connection, from the ISP. From the content, the CDN, the wherever that data center is, and so some of that loss is outside the operator's control. And if the operator picks a different, maybe they go to a lower budget transit provider that's got a little bit more loss on it because their links are constrained, that would make the ISP's numbers look worse and not necessarily be something the ISP can do something about. Generally, if we're talking about pathological loss, it's going to be 10% more, lots of loss, and ideally that is a temporary situation that the operator can fix because there's something actually wrong in the network. The normal amount of loss that occurs is not notable. Like there shouldn't be much change over time with that. Henning's also asking if we measure link reliability, weather impact for millimeter. We don't currently collect weather stats. There are equipment that do failover from millimeter to say 5 gigahertz, and we will be collecting that data to be able to tell, look, how often is this failing over? So I would say probably we measure it, but we don't publish it yet. So give us some time, and we may have some stats on that.
Yeah, and I'll add a quick thing on the retransmits. I find that, yes, they happen all over the place. The shape of it tells you if you have a problem in your network. So if it's not a flat line, and then the level of it is related to plan speed. The higher your plan speed, the lower the retransmits, because your shapers are dropping fewer packets. So those are sort of the universal truths that I've seen with some of our data. I think we're at 3 o'clock here.
We're at time, and we don't have any more questions.
So let's
perfect.
Let's call it a day here.
Thank you, guys. I really appreciate it. It's been an awful lot of fun. And thanks for the really great questions. That's why I had Gerrit come on, so he could just grill me, and you guys did a great job too, giving some additional questions in there. Thank you so much.
Yeah, thank you, everybody. It was a real pleasure. Thank you, Jeremy.
See you
soon. Enjoy the rest of your days. Yeah, bye-bye.